So just heads up, local time for me is East Coast US, so it's about 3:30 in the morning. So if I'm trying to bring a little bit more energy, I'm trying to bring myself up here. So again, welcome. Our talk today is about the Santa Project, past, present, and future. A Christmas Carol. Like I said, I'm Pete Markowski. I'm a co-founder of North Pole Security, and up until recently, I led all first-party security agent development at Google, where I worked with this fine gentleman, Matt White.
Hi, I'm Matt. I'm co-founder of North Pole Security. Up until yesterday, I was the Santa project lead at Google, and before that, I was the original author and lead of the endpoint security framework at Apple.
So today's talk is going to be broken up into 4 sections, sort of like the classic story of Christmas Carol. We're going to start with a quick introduction for what Santa is, in case some folks aren't familiar with it. Then we're going to move on to what we call the Ghost of Santa Past, which is where it came from, how it was developed, how we used it at Google. Next, we'll move on to the Ghost of Santa Present, or what you can do with it today. And finally, we'll wrap up with a discussion of where the project is going, in the future, right? The Ghost of Santa yet to come. So what is Santa? I'm assuming since this is Mac, sysadmins, how many people here are familiar with Santa? Show of hands. All right, awesome. Love it. Last time we did this at Objective by the Sea, it was a little less than half, so this is great. Right? So again, what is Santa? Santa, at its core, Santa's an open source macOS security agent. It's been in development since 2014, and at its core, it's really about policy enforcement, right? We're known specifically for application allow listing, but we also do a lot of other stuff. We've added file access, authorization or control, and we've even added USB media control. In case you wondered where the name comes from, it's called Santa because it tells you if what you're doing is naughty or nice, which obviously is better than the alternative, which would be, we see you when you're sleeping, we know when you're awake, right? But the other thing that Santa provides that a lot of folks don't know about is we provide a very rich set of endpoint telemetry. And this is for security teams or admins to be able to actually see what actions were taken on a host at a given time. And this can be really useful, and it's been one of the better things that we've been really building that capability out. So a few things I'd like to call out about the project itself is that we have a few different focuses than other security tools. One of the main things we really, really emphasize is being performant. We recognize we're next to the user, and so if we're chewing up your CPU and resources, that's really a problem. So we spend a lot of time profiling and making sure that when we decide to take something on, it's not going to interfere and still provide you that maximum, that maximum impact, right? Or minimal impact, maximum security impact. The other thing is we spend a lot of time making sure that what we do is safe. And what I mean by that is we put a lot of safety measures into the system, right? We adopted ES early on. We have put safety measures in to make sure that you can't brick the fleet with a bad rule by blocking Santa, blocking the sync service, blocking critical system binaries, right? Because it's very easy to sort of foot gun yourself with this, with great power comes great responsibility kind of thing. And so we take that very seriously. Additionally, when deployed in lockdown mode, as we just saw from the Zentril talk, it can be a very effective control. We've seen it catch things in the wild at multiple places, and this is something that we often hear from folks in the community, and it's really great. But the other thing I'd also say that comes with the performance and comes with the safety emphasis is we like to play well with others. Santa was a tool that grew up with other security tools, and so part of our emphasis on the performance is to make sure that we can actually coexist in your environment with what you have today. And this is something that we'll come back to later, but it is a very big, important part of the project. So again, we can be deployed next to your EDR or other tools. And finally, the last thing I want to call out here is that Santa is very much built for this thing that people are kind of calling guardrail style security. So what is guardrail style security? The idea is that your security teams should set up the tools and processes by which users can actually like self-approve, right? Or like approve themselves without involving the security team, right? You put up guardrails and let them go down, go down the road. The analogy has always been, imagine you have a bridge over a high cliff, right? If there's no guardrails, how fast are you going to go over, over that bridge? But as soon as you put the guardrails up, it's safer for you to go there. And so the thing digitally, in order to do this, you have to do a few things that are, not always obvious, right? And the first thing is you have to come up with a way for security to like actually define what is too risky, right? What is above the line of risk, what is below the line of risk, and how do we measure that, right? Additionally, your enforcement tools, so things like Santa, have to then be able to supply all of the context so you can send that data back to something like a risk engine, which says, okay, this is how I know that you're programmatically above the line, too risky, go get security. Or no, this seems fine, go ahead and improve it. And when I say risk engine, this could be anything, right? There's people who have very complex setups, and there's other people who are just like, yeah, we just check VirusTotal. If it's on the list of known malware, that's our risk, right? And that's how we calculate it. So the other thing about this is that the other half of the equation, right, is approvals. You have to make sure that your users can actually get, through the process themselves, right? You don't want them to sort of stall out. So it can't be too complicated. It must be lightweight, and your tools have to help them through the whole process. I'd emphasize responsiveness here because, again, you're pushing folks into a workflow, and you don't want them halfway through where your users get frustrated, and you don't want it to be opaque. So speed is very important, and responsiveness is important. And then the other thing is you need to make sure that they can actually alert security. Now, mind you, we're doing this programmatically, but again, we're pushing it down, this risk, and across your organization and down to your users. So while we do the best we can with what we know, sometimes there's going to be things that just aren't known, right? VirusTotal doesn't have the definitions of all unknown malware. And while we'll lock it down and stop it, you can still potentially improve it. So again, you need to have that button that says, I need to raise my hand and go get security. And the last thing I would say about this sort of style of guardrail security is the process needs to be incremental, and you need to monitor the impact. So trust, but verify. And the way that we do this in Santa is through social voting, which Henry just went over for the last 20 minutes, and we will touch again, but also through the sync protocol. And so the sync protocol is how you would manage rules on a fleet of Santas, right? So we have a sync service. The protocol is defined as to 4 distinct like HTTP transactions. And all of this is documented up on our documentation site, which I'll send you to northpole.dev. The first step is the pre-flight step. And in this step, right, the Santa agent will then send up to the sync service just data about how it's operating, right? I'm in this mode, I'm running on this OS version, I'm this version of Santa, and that will go up to the sync service. The service will then respond with the configuration that it wants the agent to be in at the end of that sync, right? And this is how you can do things like toggle modes like monitor or lockdown. It's also how we do things like USB control, right? We set that on, set it off. Additionally, the sync service can also request that Santa dump all of its rules at the end of the sync and fully resync from the sync service. And this is important because if you get out of sync, this is how you recover. The second step is the event upload. And this is every time you get a blocked execution, we record that context, we send it up to the sync service. This is how you get into that sort of risk engine and measurement, right? And again, this is everything you'll need for approvals. We store it, and then we send it. Yep. And then finally, the third step here is that Santa will then fetch its new policies through the rule download step, right? And this is an incremental thing, and it's designed to be, again, remember we've emphasized responsiveness. It's designed to just by default, unless you ask for a full clean resync, to pull in just those new policies, right? Maybe you upload an event and we just automatically approve it. You want the user to feel that as fast as possible. And so you pull it back down. But it's important to know that Santa does not apply the changes yet. And that's finally, we have the fourth step, so we call post-flight. And right before the post-flight step, what we do is we take all the configuration from the pre-flight, all of the rules that we downloaded together, and we apply them atomically. And if that's successful, we move on and we send the post back up. If it's unsuccessful, we roll that back so that you're in the right configuration. We don't want partial application here, right? Because if you switch to monitor mode and somehow you didn't get any of the blocked rules as part of this transaction, now you're in a permissive state, and it's really just a messy thing to try to have to clean up.
Right. So we just saw a lot about how you can configure Santa, but what is Santa? What is actually running on your device? To introduce these components, we're going to step through the life of an event. Our main component is the Santa daemon. This is responsible for policy enforcement, logging all the telemetry, things like that. It does that by listening for incoming events from various external sources, so endpoint security, disk arbitration, things like that. Gonna take a quick tangent. I'm sure a lot of you are familiar with endpoint security, but for those that aren't, give a quick refresher just because it's a big part of this talk. This ES was released by Apple in 2019 for macOS Catalina, and it was designed to allow your antivirus, EDR products like Santa, to be able to ditch their CEX and implement everything in user space. It provides auth and notify events that a daemon like Santa can subscribe to. And what happens is when some operation occurs, ES is responsible for being in line with that operation, gathering appropriate context for that event, and then sending a message out to user space. For auth events, that message send is synchronous, and it's waiting for the client to respond to either deny the operation or allow it to continue. And then notify messages are asynchronous. So message is sent, but the operation is unblocked immediately. All right, with that context, back to Santa. So if we assume for a moment that we're going to talk about an auth exec event, Santa will receive that rule, start gathering any information that's necessary to begin applying policy. And it does that by looking up rules that are stored in the local rules database. Once it looks up that policy, it responds back to whether or not to allow that operation. If we then say, oh, we're going to deny this execution, that context gets stored into an events database, and then the event upload phase of the sync that we just talked about, it will pull those events from that database there. And then finally, whether or not you deny or allow the exec, that will get stored as part of the telemetry. And then addition to execution, so all sorts of events that Santa now logs, and we'll dig into those later on. So continuing, when something gets blocked, Santa will show some pop-up that we just saw. It will give basic information about the binary that was there, and then provide the user a chance to remediate with some exception flow. At the same time the GUI is displayed, another component, the bundle service, is spun up. And the goal here is to fetch additional information about that image that was just executed to determine if that bundle contains any other binaries. And if so, events for those are created and stored in that events database at the same time. And this is important because it allows your sync server to be able to generate events for all the binaries contained within a bundle and send down an exception for everything simultaneously. So this tremendously improves overall administration and really helps reduce friction for end users. Last step of processing an event is to just record some basic metrics. This is understanding things like event counts, processing times. A lot of it is more useful for debugging Santa itself. And then metric service periodically runs, collects those data, sends it up to the configured metric server. Important to clarify, we only send to the configured metric server, and then out of the box, there is nothing configured. The sync service is a standalone agent, and this is responsible for implementing the client-side portion of the sync protocol that Pete just stepped through. And it acts as a bridge for the daemon. It sends down new rules and settings that are received and uploads those events. And then finally, Santa CTL is a command line utility for interacting with Santa. You can do things like show important status information, run policy, or get a policy for arbitrary files, and triggering immediate syncs. It's also important if you don't have a sync server configured, you can also use Santa CTL to manually add and remove rules.
Cool. So again, kicking off our Christmas Carol theme here, the first ghost in that story is the ghost of Christmas past. So let's talk about how Santa got to where it is today and how it was used at Google. So again, originally, Santa was developed at Google. And when we were there developing it, everything was entirely in the open. So I want to emphasize for everyone here that if you saw all the code up on GitHub, you saw the same stuff we saw. The only difference was when we were done, rather than building from GitHub, we would slurp it back down into Google, where we'd pull it into Piper, Google's like source control system, and then from there we would build our binaries separately off to the side, and we would start working with that. To distribute binaries, Google maintains its own, custom package manager, and additionally, we would ship our MDM config with our own internal MDM. Now, if you're hearing custom, the reason for this is the size of the Google fleet is well over 100,000 max. So it's pretty big, and at this point, you have to do something to accommodate that scale. How we managed rules at Google, most of the endpoints are in default deny mode or lockdown mode. And when I say most, I mean well over 90%. So this is the majority case by far. Obviously, at the scale we just talked about, where we say over 100,000 machines and over 100,000 users, having a single security team where your ratio is usually like 1 to 18 or 1 to 20 for security engineers to users, it's just not possible or feasible. And so, you can't maintain allow lists with a central authority. So instead, we lean into the social voting process that Henry, again, went over just before this. We're going to touch on social voting quickly. It was first presented by Matt Doyle at Mac DevOps Vancouver. And we're not going to go into as much detail as we just saw, but we're going to touch on the basics very quickly. So again, with social voting, by default, with most of your fleet running in lockdown mode, nothing's allowed to run. Right? A user comes by and they want to run something. They get the Santa pop-up. They go to the back end. They approve it themselves. Still can't run it, right? And at Google, we had this policy that you needed to have at least 2 sets of eyes look at something before you approved it. And also, we'd run it through VirusTotal beforehand. And so you'd get to know whether or not this is known malware, but also you'd get to see if it was sort of sketchy. And this has a lot of great properties to it, right? You don't get I was playing Discord at 2, I was on Discord at 2 in the morning playing games, and somebody randomly handed me this thing and said, you got to try it, right? That goes away. The other thing is when you say, oh, I downloaded this thing off of the dark web and decided I needed this for my job, again, nobody wants to approve that, right? So you have this social control that goes with it where, nobody wants to be the one to show up asking for somebody they see, not the security team, right? Because you're asking a peer and saying, will you please approve this sketchy action so we can both go on the audit log and say that we did this, right? It's like, will you help me do crime, please? And so again, it's just really great because it stops a lot of that stuff. So again, moving forward, you find the other user, you get them to approve, and we'd hit the local threshold, right? At this point, we'd push down allow rules just to those 2 hosts, right? And the rest of the fleet's still in lockdown mode. So if we made a bad decision and something goes wrong very quickly, you'll see it here and it's contained. But at this point, we've hit the local threshold, at which point afterwards, additional users will then be given the allow rule. And the reason is we want to reduce toil and friction, right? And again, when we say we give them the allow rule, they're going through the system, we're checking through VirusTotal and our sort of back end. We're saying, okay, it's fine. And again, the thing I'd like to call out here is, again, the downvoting part. You can report to security and say, something is wrong, we've missed this, please go get an admin. Help, I'm raising my hand, right? I need help right now. And this will shut down the voting, and then at that point, right, an admin will come and they'll say, oh, no, this is fine, it just looks sketchy, or nope, it is actually sketchy, and now we know exactly where it is on the fleet. And again, it's contained because at this point, the binary or the malware can only run from the green host to the green host. And so again, assuming nothing's wrong and voting is reactivated, or they never downvoted in the first place, we eventually hit the global threshold, at which point we then push out an allow rule. And this, again, it goes out to everybody in the group or the fleet. And this is great for dealing with things like auto-updating applications like Figma. right? Where you're getting this happening all the time, and then you quickly converge, right? And so we set a threshold of about 20 when we were at Google, because you'd get these auto-updating apps, and within 20 minutes you'd converge, or an hour. And again, this is to prevent alert fatigue, and we want to make sure that when you see the Santa dialog pop up, it's something you're taking seriously. So a typical release at Google would start where we do development, right? The team would do the development. You'd see us pushing stuff out up on GitHub, right? And then we'd get to a point where we say, okay, we need to run CI/CD. We need to package it up and see what that looks like. And so we created a branch called Super Unstable. Now, Super Unstable is just the Santa developers and some test machines that we had. So we'd package it up and we'd throw it to Super Unstable. We say, okay, we do this a bunch of times and be like, all right, we're good, we're happy with this. We've decided it's time to do a real release. And so at that point, we then promote it to Unstable. And Unstable was about 80 power users who had opted in and said, we want to run the bleeding edge. We want to give us your latest and greatest. And again, it was great. Admins, power users, you see all sorts of stuff. I have my own special custom way of doing this. I have that, right? And we'd get that feedback early and quickly. And so again, assuming we're monitoring this with our metrics and crash logs and other things, right? Assuming we didn't see anything, we then promote to testing. And testing was about 2,000 users that said, I want your latest, but not your bleeding edge. Just give me it after they've looked at it. And assuming, again, that testing checked out, we'd start promoting to stable. And we'd do this as sort of phased rollout, where we'd pick 1% of the hosts in the fleet randomly, and we'd start rolling out. We'd promote to 5 and 25%. And now, by the time you folks probably saw a release up on GitHub, we'd already crossed the 50% like threshold. And at this point, you're not really seeing a lot of defects. We've been on a lot of machines and a lot of diverse populations. The one thing I do want to call out here is, as we finish this process, is that we noticed something in the last year. And that is, when we'd cross the 50% mark, you all would take the releases, push them into a bunch of different environments, and suddenly we started getting a whole different set of reports or comments from the fleet, from the community. And in the last year, Santa, the core of Santa has matured enough that you guys are the ones who are mainly finding anything that's different with the system, or finding the bugs, or finding the features. And so that's really thank you for that. And so, again, to finally recap our time here, prior to 2021, Santa was a 20% project. In mid-2021, we formed the team, and that's how Matt and I got involved in the project, right? And we did some things, right? We added some new rule types, we deprecated the Kext, and the thing I guess I would like to really call your attention to here is that we actually gutted the entire project in 2022 and did a massive refactor. And we were able to pull it off because, again, we had this process, we set it up, and we matured everything. And so this took most of a year, but it really laid the foundation for all the new features that Matt's going to talk to you about today.
All right. So second Ghost in Christmas Carol is Ghost Christmas Present. So in the spirit of sharing and giving, let's talk about what open source Santa can do for you today. So we're going to start with everything you can authorize. So being able to block mounting USB mass storage devices had been a long requested feature. We currently use a combination endpoint security and disk arbitration frameworks that allow us to prevent those mounts and also grab appropriate properties for all the telemetry. We also provide the ability to optionally configure and force specific mount flags be set. And this can be great if you want to ensure that a device can only be mounted read-only, if you want to prevent leakage of files to those systems. Or maybe you want to set the no exec flag to prevent binaries from being executed. All these settings can be set by the sync protocol and to provide an exception flow to users. And we see the example here on the left. The message you display to the users is configurable. You can describe your policy when they plug in the device and get blocked. And you can obviously control the link here and see and send them to your exception portal. Binary authorization was Santa's longest and primary purpose. So anytime any new image is being executed, Santa interjects, evaluates the properties of that binary, and then decides whether or not to allow it. We have a handful of supported rule types these days. Historically, this was just binary hash, cert hash, and path. We've added in support now for CD hash, signing ID, and team ID as well. We'll dig into that in just a minute. Transitive allow listing is an advanced feature to support developer workflows. So this feature allows for automatic rules to be created anytime executables are created by some configured binary, such as your compilers. This can be a tricky feature to configure. It's important when creating these rules to really focus on what your toolchain is doing and what is responsible for creating those final binaries. So if you're working in like a Clang workflow, right, LD would be responsible for ad hoc signing for local development, or bigger builds might be using the CodeSign utility. But different toolchains use different processes. So as we try to expand what is supported out of the box, we're continuously working with your feedback to figure out what we need to do to expand to how we can monitor and create rules for these binaries. This also requires a lot of interaction with Apple. We've had issues with just various bugs over time where different properties aren't set in specific ways that allow us to create these rules. Recent example, Golang uses memory maps constantly. That was improved in the API. We're able to adopt it, and now we're able to expand transitive allow listing feature. So yeah, important to call out we'd love hearing your feedback here for this. If you're having issues with toolchains, please come talk to us. We'd love to help dig in that with you and help get those rules set up. We have 2 modes that can be configured. We've heard a lot about at this point in time. So lockdown is our default deny mode. So that tells you if there's no specific allow rule in place, then that execution is denied. Conversely is monitor mode. If no specific block rule exists, then it will be allowed. So on the left, we see what this looks like here. Various attributes of the binary get displayed. And again, you can control the message that's displayed to describe your policy and control where they go for the exception. All right, we just mentioned the various rule types supported by Santa, but this is pretty integral to how this works. So I want to dig into this in a lot more detail. So here we have the various rule types that are there, and these are listed in order of precedence from highest to lowest. The Santa policy engine is a first match system, so if you have multiple rules that apply, the one with the highest precedence type will win. So I'm sure many of you are familiar with these types, but if you're not, want a refresher, let's step through an example. So here in this app, would be just a common bundle, and it has 2 binaries in it, example CTL and example D. So using that app, let's assume there's 2 versions floating around. Our rule type with the highest precedence is CD hash, and this value uniquely identifies the code being signed. And you can see each binary and version has their own distinct value. And then next is the hash of the binary, which also uniquely identifies a given binary and version. And we use SHA-256 as that rule identifier. Signing IDs are identifiers that developers themselves give to a binary, but this identifies it a unique binary across versions, which makes it a little more stable. This isn't technically guaranteed. The signing ID is under control of the developer, but it's rare for these to change. Apple provides incentives for developers to keep these stable. But signing IDs can be very beneficial from a maintenance standpoint. You don't have to create allow and deny rules every time some new version of a bundle comes out. Next is cert hashes, specifically the SHA-256 of the Leaf cert. And these apply to all binaries signed by a given organization. And they're useful to create a rule that generally applies to all binaries within a bundle. However, the rule only applies to things that were signed during the time which the certificate was valid. So in our example, we introduced a new version with a new cert hash that was used. And this can happen all the time. A common one is just expiration. Team IDs similarly refer to all binaries produced by some organization, but they're not constrained by that cert lifetime. It's also good to note that Santa only respects rule types with code signing properties like CD hash, team ID, signing ID for validly signed binaries and binaries signed with production certs. Finally, it's possible to configure policy for specific path regexes, but it's important to note this is not a rule type per se. It doesn't come from the sync protocol. This is just part of your main Santa configuration. Obviously, this doesn't refer to a particular binary. Anybody could change out the binary under that path at any time. So this has been around in Santa for a long time. It enables some escape hatch scenarios, but we discourage its use because of how unsafe it is. So if we put this all together, keep in mind that Santa is a first match system. Some interesting ways you can layer rules. A common way is just to block a specific product from some organization that you otherwise allow across your fleet. So we start by just setting up a rule for an entire org. So example TID here. But let's say your company has a policy against third-party cloud storage solutions. So you could then use a higher precedence signing ID rule and block that specific product. File access authorization is a massive feature. We just took this out of beta last year. And it started out as a desire to prevent or monitor access to specific files from unexpected sources. So the common use case we heard from security teams was, hey, how can we block cookie theft? Before this was implemented, we had ran into several issues during the design phase, namely that the system APIs at the time were just not performant enough for this to get done. Luckily, we had a good relationship with the ES team at Apple, reached out to them, started a conversation, went through our use cases, challenges, and were able to collaborate on some really good API. Awesome folks at Apple were able to land this new API, and we were able to adopt it and enable these powerful features like FAA. Again, on the left, you see a common block dialog that we've seen before. This time you get, what path was accessed, what process was, violating that rule. And again, you can control the message to describe your policy and where that exception portal goes to. The FAA policy is a standalone file currently or it can be embedded in the MDM config. And this is a plist. And there are very rich options for describing this policy, and highly encourage you to go to northpole.dev when you're configuring these. There's a lot of options. We're going to step through a basic one here just to sort of touch on what's available. So as I said, it's normal plist. Start with just common header and footer, and we have some root keys. The version here is useful because this gets added to your telemetry logs. So when you're looking at some violation that occurred, you can know what policy was effective on that system at the time. And then after that, you define the set of watch items or the rules that you're interested here. So let's define one. For example, we're going to look at Chrome cookies, and we're going to block that access. So we start with a good name, and then for each watch item, we define 3 sections. First is paths, and these are, the paths are important to this rule. These can contain globs, they can be path literals, you can do path prefixes if you want to watch some entire directory tree. And here we see we just define a single path. This watches our Chrome cookies for all users. Next section is options. And for Chrome cookies, we've defined 2 rules here. First is allow read access is set to false. We want to block all access, not just modifications. And then second is audit only is false, because we want to block this, not just log it. So there are several other options that we don't list here. You can have, per rule customized URLs and texts. You can enable silent mode, and a whole slew of other things. So again, please go check out those docs. The last section here defines the set of processes that are exempted from the rule. For example policy, we first define Chrome, because obviously Chrome should be able to read and modify its own cookies. But we also exempt Apple's Spotlight service, MD Worker, because we don't want to show frivolous pop-ups to the user or generate noisy logs. For an exception to apply, a process being evaluated must meet all the conditions of a given dictionary. That is, the attributes are ANDed together. So for Chrome, for example, it must have the proper signing ID and team ID. So FAA rules have been useful in a variety of situations. Recently at B-Sides Las Vegas, Nick Frost from Figma gave an excellent talk on blocking Chrome cookie theft, stepped through some really cool examples. I would highly recommend you check out that talk. In addition to Chrome cookies, there's other things that are interesting to be on the lookout for, bearer tokens, or maybe you have some really sophisticated detection set up and you want to do your own honey tokens. Locking down system configuration is another really big option here. We saw the allowed read option, config files. You want to just prevent modification, but you can be generally read, right? So maybe you want to lock down modification to your SSH config or sudoers file. And then last, I just want to emphasize that the policy that's available here is extremely flexible, and it gives you a lot of options for being able to define really targeted policies. So we saw in the example how you could limit Spotlight from generating frivolous pop-ups. And good policies will evolve over time as you monitor alerts and logs on the back end to exempt more things from the policy. And this flexibility just allows for really high signal-to-noise ratio. In addition to the various authorization stuff we just saw, Santa provides really rich telemetry for a whole set of events. So super quick step through this. Process lifecycle, so exec, fork, exit. File operations, these are file modifications, renames, unlinks, and more. Process meta events are interesting, so when some process's code signature becomes invalidated, maybe because it loaded some unsigned code. Disk mounts and unmounts, and then we're also now adopting a growing number of user space events. So your login, logout, OpenSSH login, logout, screen sharing, attach, detach, things like that. Each of these events are sent through Santa's enrichment pipeline, and this is responsible for tagging these events with a whole set of relevant metadata about what was going on in the system at that time. So what does this look like? All the telemetry can be logged in a few different ways. Traditionally, this was a mainly text-based log, key value pair, and it was backed by file or synthesis log. This worked great over time, but the format started becoming restrictive as we logged more and more event types, and especially as we started to throw more enrichment data in here. To support these larger data sets, we moved to supporting structured logging. So this is hard to read, but that's kind of the point. So the exec event here versus on the previous slide, we're able to stuff just a lot more things in here. And this just starts to become very actionable for your security teams. With Protobus, we get better type support and a really performant library that allowed us to meet our performance goals despite logging more data. So if you're ingesting telemetry, Protobuf is definitely the way to go. Some neat additional things you get in the Protobuf logs compared to those key value pair logs. You get environment variables in addition to the process args, file stats for the targets of all your operations, file descriptors and types we'll touch on in a second, and process entitlements, which can be kind of eye-opening. A lot of things not covering here, but we have a whole Santa proto schema. It's heavily commented, and that acts as our main source of documentation for these events. So what can you do with this? Just a small sample here to run through some really cool things that people have started doing. We include the group IDs and session IDs in these events now, so you can start to build up more context around what a user was doing on this system, build up little process trees. Usernames, we grab, we get all the IDs from the event, but then we associate those IDs with the usernames that are on the system. So UIDs, GIDs, the real and effective IDs, all of that gets logged. That helps you on the back end associate what LDAPs might be associated with some of it. Process args and environment args obviously let you build up or understand more context about what a process might have been doing on a system, what its capabilities might have been. For execution events, we know the IDs before and after the exec VE call, so we can see those set UID transitions, and you can know what set UID binaries exist on your fleet. The file descriptor info is pretty cool. We started pulling those in as well, so we know everything, the file descriptors and their types for like standard in, standard out. For things that are pipes, we also pull in the pipe IDs. And as we see, you can start to build up graphs on your backend to understand how these processes are communicating. Maybe you want to learn on curl pipe to bash. That might be interesting to look into. Mount remote addresses, so SMB shares, you can see where that mount from was, that remote address was. And then events tied to user activity. Now that we have login events, you can know when something was executed by a user and the user was at the keyboard, or were they not? That might be interesting as well. Then finally, entitlements. It can be really eye-opening to know what is on your system and what has potentially dangerous entitlements. They might have good reasons to have those entitlements, but maybe you want to know what binaries have disabled library validation and can load third-party code, or has maybe even disabled various bits of code signing enforcement.
Cool. So now that we've talked about all the things you can authorize in our telemetry, let's actually try to put this in context for an attack, right? So I was told I need to add a banana reference to this talk. So to our initial access vector for our attack, the attacker is going to send a spear phishing email to somebody and try to get them to run the malicious banana.app. And the thing I want to point out here is that if you're running Santa in default deny mode, again, it won't run. You're going to get pushed into that guardrail style security flow we talked about earlier, so we can stop the attack here, because you have to get somebody else to approve. And not only that, but also we're going to run it through other scans and other things in the background. But let's say, okay, it's just we're going for it. They just approved. Okay, cool. Now what do you want to do, right? Often you want to do the same thing again. You'll have a dropper or some sort of thing that will download a second stage payload. Again, social voting, binary authorization, we got you covered. However, let's say that that's not your goal. Your goal here is you want to steal cookies at the end of it. Well, ultimately what you're going to do is you're going to start setting up some sort of persistence mechanism. And this is, again, why we're so excited about the file access authorization. We can control access to these directories, read and write, and say, okay, we're going to pop this back up. Again, push you back into the flow, right, and get that going. So again, we've got you covered here. And then ultimately, right, once you've established a beachhead, the other types of things you want to do are move laterally. And often this comes from unsecured credentials. Maybe you want to go read known hosts to find other hosts to propagate into, right? And again, we can lean on FAA here to watch these things and say, hey, this is aberrant. We're not going to stop you. We're going to bring it to the user's attention, but we're going to let them work normally, on the happy path, as it were, right? And then finally, again, as Matt just talked about with FAA, right? If your goal is to ultimately steal the web, cookies and get through that, we're going to give you some really hard rules, like only Chrome signed with Google's build key is allowed to open and touch the cookie jar, right? And I feel like if we've raised the bar enough where it's like you have to bring a Chrome exploit to go get this, I feel pretty good about that. And the other thing I want to leave you with here is, again, as Matt talked about with the telemetry, we're recording telemetry at all of these different stages as well. So even if somehow we miss everything, we still try to get you covered at many stages across this. So like we'd mentioned earlier, it's important for Santa to be compatible with other tools. We grew up around other tools. And so in that regard, we've built a few integration points we'd like to talk about quickly. We have rule level customization, right? So oftentimes the Santa dialog is the first step in a workflow. And while social voting is great, and you should absolutely do it if you can and run in lockdown mode, there's going to be some times where you want to drive a user to a separate workflow, right? And there's a few ways we give you, handles to do that. And the first one is we provide a custom message field in the rule, and that's been there for a very, very long time. So you can control the text that pops up. Another thing that we've added in recent years is the ability to customize the URL that the open button will take you to. So let's say, for example, you have a workflow where I need to use WebEx or Zoom or something, but I only want to approve it for an hour, and we're fine with it being self-approval. The way you would do that is you would set the custom URL field, and then from there, when the user gets the Santa dialog box and says, oh, it's blocked, you click open, and instead it'll drive them to something else that will start that flow, and then we can get that policy down. Another thing that Santa does that a lot of people really don't know about is whenever we block an execution, we also publish a distributed notification. And the idea here is other tools that are on the system can then react based on when we notify them, of like, hey, we've just blocked this thing. And this is great for a lot of things. You want to debug execs. We know there's one Santa user who's built an entirely separate UI, so they block everything silently and they wait for our distributed notifications, and then they pop up a very branded company UI that drives people down their workflow. The other thing is you can use this to connect stuff together, right? You can go hit a webhook whenever we block something. Or the other purpose, which is one of the reasons we added this, was maybe you want really fast collection of that binary on the host, and you want to go forward into like VirusTotal or some analysis pipeline. The thing is, this is a pain in the butt, and you still have to write Objective-C code to do this. So to make that easier, we wrote a tool, which we call Santa DN dump, and all it does is it listens for the notification, like in a command, converts the NS dictionary you get to JSON, and then spits it back out to standard out, and you can wait again. And so the neat part is, and if you go look at the repo, you can actually, in about 3 lines of bash, write a script that just will take whatever's blocked and immediately upload it, just with a form post. So you can use curl and the script and just be like, yep, off here. So again, I'm really excited to see what you all build with it. We have a little demo here, so if you bear with me. Right, so Ragged is my laptop. I'm running Santa DN dump over here on the right. I run my sacrificial binary, which is always OSA script, because it's in all the Red Canary reports as attacker used OSA script. Right, you can see here, we block it. But over here on the right, you have all of the context that we put in the dialog. So you can do anything you want with that, hand it off to JQ, chop it up, slice it, dice it, make julienne fries, see where we go. The other thing I guess I'd like to call out is we've added a few different ways for you to get rules into Santa over the past few years. This started when we added static rules, right? So we know there's some people who don't have a sync service, or they don't have environments that are changing that much, and they just want to manage it all with MDM. So we added that. Sync service we talked about earlier. But then the last thing is, the command line, right? We've always had Santa CTL rule. However, in the last few years, we've also added a JSON import-export option. And so the nice part is you can actually create little rule packs that you can then share across things that are not necessarily connected. So maybe you don't have MDM, maybe you have an isolated system, maybe you have something else. But you can just take a rule pack, generate it as JSON, put it up on a gist somewhere, share it with somebody, and pull it back down. And the other thing I guess I would like to call out about rules is there is a second level of precedence, which is always too complicated, which is static rules will override anything from the sync service and the command line, right? Just like the sync service will override and shut down the command line. And the reason for this is obviously, there's some things you want to make sure are absolutely out of bounds for voting on. Maybe you have security software, things you need for compliance, or whatnot, or just general things. So again, we don't want to make it so it's hard for you to back out of a decision and stay safe. So, all right, we're coming to the finale here, the ghost of Santa yet to come, and the future of the project. So, all right, in the last 2 years, we've really seen the community grow. We've been approached by a lot of people who are using Santa, and also a lot of people who really want to use Santa. And as we've seen this, we realized and we felt that this required the resources of a company fully dedicated to this project. And so, as you've probably noticed from the slides and our watermark that we've had up here for the last almost hour, we formed North Pole Security. So who is North Pole Security? Well, I've been talking to you for a little bit. I'm Pete Markowski. I'm the CEO. Joining us is Russell Hancox. When we say that Santa was a 20% project at Google, it was Russell's 20% project at Google. Also joining us is Tom Bergen, who some of you folks may have known. He's the folks who've been in this community for a while. Tom joined Google through his Santa contributions and came and became part of this. And then finally rounding out the team is Matt White, who's been presenting with me. So let's address the elephant in the room. We are forking Santa. The new repo will live at the address you see here. It's already up. You can see that we're still trying to set some things up, so bear with us. And we know that the community is important, right? We just want to emphasize we're the ones, we've been doing this, we're the ones you've been interacting with on GitHub and Slack, over the years, and we're the ones who you've probably seen late at night trying to make sure we get your issues, addressed at least, if not bug fixes and other things. And we're going to be the ones you continue to interact with, and now we're able to fully dedicate 100% of our time to this project in a way that we just couldn't previously. So again, these are our commitments to you, the community, right? Santa will stay open, we'll be there. We're going to continue to work with, and stay compatible with the sync servers that implement the sync protocol. And if we find some issues like we did this summer, we will work with everybody to make sure that we stay compatible and that everybody gets to the right place. We want to be able to help you make this product fit in more diverse environments. We want to be able to spend more time working on issues from you, our users. And so let's talk about what we can do as a company that we weren't able to do before. So let's talk about an experimental or beta feature we've had baking this summer. We call it Standalone Santa. This is a beta. And basically what you can see here is, by default, we have file info. You'll see it's blocked. I run OSA script again, which is my sacrificial binary. And now when you're running in standalone mode, you can use Touch ID to approve locally, right? And what will happen is if this binary is validly signed, we'll add a signing ID rule for you. And if it's unsigned, we'll add a SHA-256. And again, you can see right there. And so this is great when you have those sort of standalone systems or you have those kiosks or other things you want to configure. So you can, again, remember we talked about rule packs earlier? Put something in standalone mode, do the activity you want, generate a rule pack, export it, and then take it to another system that you want to put in lockdown mode, right? Again, it's another way for you to get these rules and get them here. But again, this is beta. We have other things to do here. You'll see this at some point. We're going to talk about the roadmap quickly and then wrap up. So there you go.
Yeah, as Pete just said, we want this to be a really iterative process with you all. And we've already been hearing feedback from you. We have some big ideas here that we wanted to share on the roadmap. So we just saw standalone Santa, but we also have a whole set of new telemetry that we're going to be adding here quickly. But in addition to that, we've heard that some of your environments, you need sort of a reduced volume. Like you want better control over what gets logged, what events are enabled. And being able to add those controls for you is what we want to add here. Later on, we're going to be expanding what you can do with FAA to make it even more powerful. So currently, we saw the rules are very path-centric. And this is great for locking down specific items, but you need to know what you want to lock down to be able to set those rules. So another way we can look at this is through process-centric rules. And this would allow some really cool data loss prevention scenarios. For example, say you want to configure and watch zip or tar to know what sort of files are being brought in to these bundles. And then later still, we have plans for more detections in the form of file content checks. This would enable Santa to get some insight into the types of things that are being created on your system, and be on the lookout for all sorts of different things. Maybe you want to prevent leakage of API tokens. And then we can even automatically create FAA rules to begin auditing that access. So this is just a sliver of what we have on the roadmap here. And like all good roadmaps, things become fuzzier the further out. But as we just said, we really want this to be iterative. We really want to hear your feedback and what is important to you that we can get into Santa.
And so the last thing we want to leave you with is an invitation to come join us, right? The project is moving homes, right? This is our new GitHub repo. We've moved the doc site as well, so we're up at northpole.dev. You may remember santa.dev. And finally, we're going to be on the Mac admin Slack in the Santa channel. We're still there. Please bother us. We actually love it when we hear from you guys. We love fixing stuff. The other thing, again, other discussions, issues, PRs, we have more time. We're happy to help. We want to help. So if you folks want to, take a stab at some open source development, we even have some time where we can help mentor and get people, shepherd people through PRs and that whole work. And again, we'd love your feedback. So thank you.